This is Rumbod. In this video, we're setting up CLion for modern C++ development using Raylib, CMake, and Vcpkg. CLion is now free for non-commercial use, and that's a huge deal for C++ developers. It's a professional-grade IDE from JetBrains, designed specifically for C and C++, with deep support for real-time debugging, smart CMake integration, and powerful tooling out of the box. You can download it directly from jetbrains.com. Make sure you grab the official version marked free for non-commercial use. So why use CLion with CMake and Vcpkg? CMake is the modern build system behind most serious C++ projects. It lets you organize, configure, and scale your project cleanly, especially across platforms. CLion understands CMake natively and gives you real-time build feedback, code navigation, and quick edits without leaving the IDE. Vcpkg is a library manager for C and C++ developed by Microsoft. It works just like a package manager. Instead of hunting for headers and binaries manually, you just search for a library and install it. CLion supports Vcpkg right inside the interface. You can browse packages, install them, and start using them in your CMake project with almost no extra configuration. Let's take a quick look at the official Vcpkg site. You can search through thousands of libraries, from graphics and math to audio and physics. It's a lot like NPM for JavaScript, but for C++. Now, before we dive into the project, you'll need a compiler setup. On Windows, you can use MinGW, Clang, or the Microsoft compiler through Visual Studio. All of them are fully supported and work well with CLion. If you haven't installed them yet, you can visit their official websites and grab the latest version. If you're not sure how, leave a comment. I'll make a full guide for Windows, Mac, and Linux if enough people ask, but most of you should be fine with the official instructions. Once everything's ready, we'll jump into CLion and connect Raylib using CMake and Vcpkg. If you find this useful, subscribing means a lot and helps me keep making tutorials like this. Once you've installed CLion, open it up and click on New Project from the Welcome screen. We're creating a C++ executable project here. I'll name this one Rumbod Dev, but you can choose any name you like. Just below the project path, you'll see the language standard option. I'm switching it to C++ 23, which is the latest version available. You can also choose older standards if your project requires it. On the left panel, there are other project templates too, like Qt for graphical applications, CUDA for GPU programming, and plain C projects if that's what you need. If you're interested in setting up Qt with CLion, let me know in the comments. I've worked with it before and can help you get started. I haven't explored CUDA yet, but I'm happy to try it in future videos. Once everything looks good, click Create and wait a few seconds while CLion loads and sets up the project. Once the project is open, the first thing I like to do is set up the compiler toolchain. Click on the gear icon in the top right and go to Settings. Inside the Settings menu, navigate to Build Execution Deployment, then select Toolchains. Here you'll see all the available compilers on your system. You can reorder them based on priority. I'm moving Visual Studio to the top, but you might prefer MinGW or Clang depending on your setup or the project you're working on. You can switch between toolchains anytime, and this flexibility is really useful if you build different kinds of projects across platforms. Once that's set, let's open the Vcpkg window. On the top left corner of the main window, click the hamburger menu, then go to View, then Tool Windows, and scroll down to the bottom of the list. You'll see Vcpkg there. Click it. Now, on the left side of the screen, you should see the Vcpkg panel appear. If this is your first time opening it, you'll need to set your Vcpkg root before it can start showing packages. Now, let's connect our Vcpkg installation to this project. Click the plus icon in the Vcpkg panel to add a new repository. You'll see a window called Add Vcpkg Repository. Here you can give your setup a name, usually just Vcpkg, and point to the directory where you cloned or installed it. You can also leave the default GitHub URL. unless you're using a fork. Once you enter the directory path, CLion will automatically download and extract the required files if needed. You only need to do this once per system. That same repository can be reused across multiple projects. In this case, I'm not clicking OK because I already have one set up from before. I'm using the one named Vcpkg Classic. And to edit that existing repository, just click the pencil icon. This brings up the Edit VC Package window. You'll see the same fields, name, URL, and directory, and below that, two important options. Add Vcpkg integration to existing CMake profiles and debug. These are unchecked by default. If you want this repository to be linked with the current project, make sure to check both of them, then click OK. Once that's done, the icon next to Vcpkg Classic changes from gray to yellow. That's how you know it's now active and bound to the project. You'll also notice CLion starts processing and reloading the project automatically. That confirms everything is synced properly. And just like that, you've connected Vcpkg to your project. Once we've connected everything, we can search for Raylib or any other library we need. When we find it, just click on it, then hit install on the right side. After it installs, a pop-up will show up. This helps us with the CMake setup. Click on Add Packages to CMakeLists, and it'll show you the necessary configuration. There'll be a line to find the package and another one to link it to your project. Copy both lines, then head to your CMakeLists file and paste them right below the line where you set the C++ version. Now just one change. In the line that says target link libraries, you'll see it links to something called main. Replace that with your actual project name. In my case, it's rum.dev, so I just swap main with rum.dev. Done. The library is now ready to use in your project. Make sure to place add executable before target link libraries, otherwise you'll get an error. After adding the lines to CMakeLists, head to the CMake panel on the left. Click the reload button. Sometimes the first reload might give you an error. Don't worry, just hit it again. Most of the time, the second try works fine and CMake detects everything. Now that everything's ready, I'm going to copy and paste a simple hello world example into main.cpp, replacing the default code. We can now build and run the project, and just like that, with the simplest setup, we have a working Raylib project. If this helped you get started, consider subscribing. It really supports the channel. Thanks for watching.